Okay, good morning. Assalamualaikum warahmatullahi wabarakatuh. And thank you for joining this session. Welcome to the next discussion about the data science in these courses. Yeah. So today we join again, and then we will discuss with the new materials that which title diagnostic analytics. Yeah. So this is the one of the type of the analytic that we need to conduct in the data science processes. Yeah. So we will try to after the midsem we will try to discuss more detail and then more comprehensive in every type of the analytics steps. Yeah. That we usually and also commonly use in the data science processes. Yeah. So maybe the last appointment that we has done before the midsem, you already know about the exploratory data analytics. Yeah. This is the one of the type that we need to do the data analytic processes that the function is to explore and observe all the possibility of the data. Yeah, so that will be the exploratory data analysis function or objective. Yeah, so in EDA or exploratory data analytics, we try to find out the characteristic of the data and the quality of the data, and also maybe one or two or maybe more the pattern that we found in the data that we already collected. And of course the exploratory data analysis not showing something that we call deep finding. Yeah, but mostly is to show how the data can interact by the data, and then the data itself will be show about the the distribution, and then the anomalies, and then representing the data into the average, mean, and so on. So that would be one of the the type of how we show the characteristic of the data, and mostly it's used the basic statistics use and the baseline of the statistic method, yeah, that we already know in the statistics course, for example. But after that, actually, we go through to the next step of the analytics that we call the diagnostic analytics that we will discuss today. Yeah, this is actually the the next step, and then and mostly is like a continuous analytic process after we do the exploratory data analytics. So the suggestion is actually for data scientists, before we do the diagnostic analytics, we need to do the EDA first, yeah, or exploratory data analytics. Yeah, like I mentioned before, it's really needed to ensure that the data set quality that we have in the data set is good enough for go further to the next analytic processes. For example, if you found that your data set based on your exploratory data analytics is not a good quality, for example, the it's very random, for example, and then the second is, for example, the data set is imbalanced and so on. So it will be give you some guideline that you need to handle the issue that issue first before we go to the next analytics here. I have some some experience with when my team, maybe you already know the ukara.ai, that with Pak Bambang Prastowo, with Bu Yunitasari, Pak Guntur, and Bu Isna, and another researcher from the another university in Yogyakarta, we do the data analytics process. For example, in that case is data student assessment, national student assessment, yeah, or ujian nasional, yeah. And we found that when we have the some of the scoring label from the assessors, which is teachers and so on, we found that the model that we have is imbalanced data set, because most of them is like the score. For example, we have a score 1 and 2, for example. But the problem is the score that reflected by number 2 is more bigger than 1, and the more bigger is very, very the range is very wide. Yeah. So for example, if I'm not mistaken, the label number 1 is only have about 15% of data, and then the rest is label 2. So what happened in that case is, when we do the machine learning algorithms, for example, to classify or to do the classification, we have problem, because the model is not appropriate, because he will very good accuracy to classify number 2, but unfortunately, when label number 1 will be will be classified in not a good not in the good model. So that would be the problems here. So that's why I wanted that one case here. The another case is about the quality of data, that maybe the data itself is consists of a lot of typos, for example, the error and so on. So that would be also the challenge there. So and make the analytics, maybe you need to more very you need to very carefully to take a look about it. Yeah. So yeah, that's, I think, that the art of data science, yeah, for when we do that this process, because we will we will very clear and very carefully to take a look about the data, and then handle the data in the good things. Yeah. Yeah. I think my personal opinion that especially in Indonesia, when we do the data science processes or activities, the main problem is always about the good quality of data sets. Yeah. So I think a lot of people already work good work on the developing the the model of the algorithms and so on, but providing the good quality of data set is one of the homework for us. Yeah. So that will be the one of the challenge for the researchers, the student or data scientists to handle this issue. Yeah. So that's why I have an idea to in this year we need to produce a data set that can be used another researcher in the good quality of data set. Yeah. So that will be the reasons. Yeah. So what is the purpose of this diagnostic analytics? Yeah. So today we will learn, and then you as student will be hopefully will be understand and catch what the idea behind the diagnostic analytics, and then how you do the diagnostic analytic. You have the guideline, and then hopefully it can be implemented for the real case for your project or your works. Yeah. Currently and also in the futures. So when we see the diagnostic analytics, actually the diagnostic analytics have very specific objective, yeah, and also explanations. Yeah. So we can see in here, diagnostic analytics is describe the techniques that you will use to access your data. Yeah. So this will be answer this question: why did this happen? So we found out into your data sets what this happened in your data. So it's actually like what the event that happened in the data. Yeah. So that will be the challenge for you. Yeah. So this is the question. So the illustration is like this one. I will use my data science project, yeah, in the COVID-19, for examples. So you can see in here that, for example, I have this case. Wait a minute. Yeah, so this is like the counting number by time series situation of COVID-19 case growth in Indonesia. Yeah. The last update is 19 April, so it will be a little bit late because now we have a problem into the confirmation about the data the data quality from the province and also the district that came to us, and we need to verify it more clearly now. So you can see in here the data and the number of data is shown by the time series. Yeah. And you can see this up and down, and sometimes it will be very huge increasing number of case, and then we also have some decreased number, and then now we have some stack number in here. So actually in this point, the interesting point that we think is showing something. So we will find what happened actually in here. So that will be the question of the diagnostic analytics here. So of course, when we do, we show this this number of data into time series graphic like this one. This is the result of the exploratory data analytics actually. And after that, in the diagnostic analytics, we need to know about why it happens here. For example, in the July 10 July in 2002, what it actually happened. Yeah, of course, we need to know about the context of the COVID-19 case growth there. The trigger is always about before the 10th of July, 2 weeks before, when we go to the back, it's always about the event that happened in the community. For example, we have a long weekend. For example, we also have some, like in that case, for example, we have some mudik event, and it's also happened when in the end of January, we have some big the huge number of COVID-19s, and then it's happened because of we have year-end event and so on. So it's also, and now it's happened now for us. You can see now the case is also, the fluctuation is very very sharp. Yeah. So that show us that the number of the event that triggering the number of the COVID-19 daily will be, it's very, it's very uncontrollable, for example. So we need to add that one. It's just like giving a label, giving a notation why it's happened. Yeah, it's also happened with the another number of the data. Yeah, so that will be the illustration of why did this happen. Yeah, so that will be the nice one. It is like same when you check your blood pressure this morning, for example. You will have the data. For example, the number of your blood pressure is, the number is like this, like this. Yeah. So you will see why this happened. Yeah. So you need to answer this question, why this happened. So what we do to answer this question is actually you doing a deep dive into your data. Yeah, to search for valuable insight. So actually, you diagnostic analytics, you go through you dive into your data and then searching the valuable insight of your data. Some of them using the diagnostic analytics, using advanced descriptive analytics here. So yeah, it is like do some a simple process that chronicles the facts of what has already happened in the event. Yeah. So in this step, you will understand that to answer this question, what this happened, we not only just capture the number of data in that point, but also we need another or additional data that describe what actually happened, the event that happened with the data. So for example, when my blood pressure today is about, for example, 130 point, for example, so you add the data with the, okay, because maybe 30 minutes before I check the blood pressure, I do the morning walk in around my house. So that's why the blood pressure is going increase, for example. So that would be the happen. And the diagnostic analytics takes it a step further to uncover the reasoning behind certain results. Yes, you can see in here, we try to uncover the reasoning behind certain results. Yeah, so what we want to see is the reasons why it happened. Yeah, so that's why the question is always why. So maybe you already have your score for your midsem. So when you found that number from the academic or something, I already submit last week. So you will also have this question, why I have that number, for example. So it's like the same actually. You need to do the deep dive. Yeah, maybe you will ask me, why, Pak Mardhani, why I have this score? I'm not satisfied. So I will show you the detail, and then you will reflect with yourself. Why in the task I only have, for example, it's only 60 point. Why in the mid-time I only have this point? So you will reflect what the reasons. Yeah. So that will be within the diagnostic analytics. Yeah. So based on this explanation, hopefully you now understand that this is very important, because we also have the question mark about why. Yeah. So that's why it's very important to you to have these questions. Yeah. And of course, the diagnostics, diagnostics analytics have a differentiation with several analytics methods. Yeah. So yeah, after this mid-sem, we will more discuss about this type, the four type of the data analytics. Yeah. Today we do the diagnostic analytic discussion, and then the next we will go to the descriptive. Yeah. And then also we do the predictive, and then we will have prescriptive. Actually, one more, yeah, that we call the cognitive analytics. Yeah, it's close to AI and yeah, the artificial intelligence. So in diagnostic, actually we use the historical data. It's same with descriptive. Yeah, using the historical data. So yeah, you must very carefully about the historical. The historical is it's mean the data is have a main attribute, which is time series. So that will be mandatory. So you take a look at your data, to your data set. It is have have the time series component or not. Yeah. And then in the diagnosis, is identify data anomalies. Yeah. So we will have the reason, we will have the answer based on the data anomaly that we capture on the analytics. Yeah. In here, we reconfigure in the descriptive. We reconfigure data into easy to read formats. Yeah. So and then in the predictive is like we do the fills in gaps in available data, and then in the prescriptive we do the estimate outcome based on the variables. Yeah. And in the diagnostics, the purpose is to highlight the data trends. Yeah. So we try to highlighting the data trends. So one of the results of data analytics is something like this one. We do some analysis about the, for example, using the interpolation and the exponential method, yeah, to predicting the data. So yeah, found something like this one. So this is the time series, and then we make some interpolations, and then we have this red line that showing the predictive, the predictions. So and we will compare with the actual data that already scale the data, and then you can see how the traction of the data. Yeah. And it's also happened in the exponential. Yeah. So this will be actually it's also happened with our case for COVID-19 in Indonesia. Yeah, the growth of based on the the trend of the data is still exponential actually. Yeah. So it's mean the add number of the case every day still exponential. Yeah. So even the number of data now is steady in this number. So that would be one of the illustration. Yeah. So we not discuss about why the data is not following the line, not that one. This is about the growth, yeah, the characteristic and the behavior of the data. And then in the descriptive, it's about describing the state of your business operations. Yeah, this is more for the business operations. And the predictive is using for creating the data model. So that's why in the machine learning, when we discuss machine learning, actually we will go from this analytic, the predictive, yeah, and also in the prescriptive, yeah. Deep learning will have the prescriptive in here, the prescriptive analytics, and then the AI will have in the cognitive analytics, yeah. And then in the diagnostics is always start triggered by some issue. So that's why in here we see that investigate underlying issue. Yeah. In the descriptive, if we learn from the past, yeah. From the predictive is do some forecast potential future outcomes. Yeah. And then in the prescriptive is use algorithms and machine learning AI to answer the questions. So every analytic have their own question word, yeah. And diagnostic is about why. In the descriptive is about what, yeah. And the predictive is what might happen. And then the prescriptive is about if-then question. So that would be the difference, the basic difference of each of analytics, yeah. And from the when we see about more, if we want to see, take a look more deep about the about this case, actually we can see from this graphic, yeah. So the sometimes descriptive analytic and diagnostic analytics we can use in the it's not in the fixed order, yeah. For example, in this case, using the descriptive analytic first and then go to the diagnostic analytic. Sometimes we go to start with the diagnostic analytic first, and then we go to the descriptive analytics. You can see in here we have two kind of method actually that we can use. Yeah, the first is in inertia, and then this is the imperative. Yeah. In the inertia, you can see that descriptive analytics can be from the using the schedule report, yeah, the business report that already produced by the organization or business entity. Sometimes using OLAPs, yeah, and then we do the data discovery, and then do some query and ad hoc reporting, and do some drill down across data analytics, yeah. We also and then if we go to the predictive, we go to the text mining and data mining, do some network and cluster analysis, visualizations, and then we make some pattern matching, and then predictive model for prescriptive analytics, and then do some simulation that get more complex, like Monte Carlo simulation, and the rest. And the next is go to the neural networks. Yeah, so that will be our type of the method that we can use for analytics in the inertia type. Yeah, but of course, when we see in here, actually we try to have the insight and foresight of the data. Yeah, and in the imperative, we also using the alert, yeah, and then do some sentiment and semantic analytics, yeah. So if you familiar with the sentiment analytics, yeah, so it's mean like using the diagnostic actually, and we do some regression analysis, forecasting, do some multivariative statistic, yeah, operation research that focus on the optimization, for example, and then do some CEP, complex event processing, and do some graph analytics and heuristic or rule engine. So that is also have same things. Yeah. What I remember with my dissertation, for example, even I working on the analytics, the data activity on the in the data center. So we using this one, yeah, using the heuristic, yeah, rule engine, and then we do some, we combine with the simulation, and using the one of the not the Monte Carlo, but another type of the simulation types. Yeah. So this is like the landscape, how the method in every step of the analytic we can use, and what is the direction. So you can see this keyword it will help you to find out which algorithm that match with your need for do some the type of the analytics. Yeah. And yeah, of course, in this case, actually, when we discuss about diagnostic, we realize that we more we more discuss into the past of the times. Yeah. So that's why we do some functionality to reflect the diagnostic. Yeah. So let's say if we discuss about this in more details. Yeah. In the descriptive, because the question is what happened. Yeah. We will present the result into the report. Yeah. And then if we want to more detail, then we will have another question about descriptives like how many, when, and where. Yeah. So that's why in here will be ad hoc reporting. Yeah. So for some case. Yeah. For why did it happen? Actually, we're using the query on three-tone analysis. Yeah. So this is will be the nice one. So for the example is the query of three-tone, for example, when I have this, for example, this one. Okay, I'm using this one. So for example, we have this data. This is the national data of the COVID-19, for example. So we have this. The illustration is this the accumulative case in national version. So we will have a drill down into the islands landscape, for example, Java. Yeah. So when we access this, we will have another data that more detail and then show the case growth in every province in Java Islands. Yeah, yeah. So that's why we will have this this graphic. Yeah. So you can hear in every graphic will show you the the number of the case in every province that related in Java, and then you can see how the growth of the data in the time series space, and also in the this is the accumulative growth. Yeah, so this is will be important too. Yeah. So what we see in here, so we will have the insight, the early insight about the data shown by this graphic, for example. So it's mean you can see that one. Yeah, of course we agree that all the provinces have the number of the case is also growth. Yeah, but the most important thing is we have a correlation between each province, especially in the province that close, yeah, each other. So the case will be, some of them is like related. Yeah. For example, the increasing number in Central Java will be is out is always and also impact to Jakarta and to another province. Yeah, something like that. So we want to show about it. Yeah. And if we go to another province, for example, it's also same. Yeah. So that will be in the case also. Yeah. This is like the in Sumatra. You can see in here, so two provinces like this one is Aceh and Sumatra Barat. Yeah, this have same traction. Yeah, increasing number is traction. That's the same in the same way. So that show that how the data is some of them is related each other. Yeah. So we can find a lot of data insight actually when we see in here. Yeah. And then in Kalimantan, for example, we will also have same case. Yeah. So that will be the showing the query and drill down data. Yeah. And then in diagnostic, we also have this one, discovery and alerts. Yeah. So we look, yeah, actually it is like giving the mark into the data, which one is make us have more attention. Yeah. So let's say I will show you another graphics. Yeah. Wait a minute. Yeah, this one. Yeah, this is the case of especially in Yogyakarta. I will show you the current situation. Wait. Yeah, this is the current situation. So we add some of the analysis that, for example, the analysis when we using the the PSBB or PPKM, yeah, the limitation of mobility of citizens. So what the impact? So we have this headline. So this is an example how we do the diagnostic analytics. Yeah. So for example, here it's more detailed. When we do some New Year's, then we go to the normal. we have the PSPP1 and then PSPP2, and then what happened next, yeah. So something like this one, yeah. So this is we made some some alert and discovery finding that we can add into the data. And then into the predictive is we have some what is the pattern. So that's why we will do the we will try to calculate the statistical modeling, yeah? And then the next is using the predictive modeling. Yeah? So that's why this is we will try to answer what will happen next. Yeah. So in this predictive, we will more discuss about what type of machine learning that we can use for basic algorithm to produce the predictive models. Yeah. And then we also in the random forest. Yeah. What if we try this, and then so we do the random testing on it. Yeah. And then do some optimization. Yeah. So this is will be the driving us to use the sum of the specific techniques. Yeah. So this is like the you know the correlation between all the the analytics that we've done, and then what the model that we can use for supporting all this kind of the report of the analytics. Yeah. So when we see this one, we have two kind of site to trigger the analytics. Yeah. The reporting side and then the modeling side. Yeah. If we only look to the reporting side, yeah, so we're only using the descriptive and diagnostic analytics. Yeah. So this is like only talk about the future based on the presents, yeah, and reporting again predetermined metrics, yeah, and then can be hierarchical view of truth, yeah, and using somewhat of if, and then detail, robust and efficient access to the truth, yeah. So and the reporting itself will be using some technique like ad hoc report, a standard report, alert, and then query tree drawn, yeah. So this is some of the technique that we use for doing the descriptive and diagnostics. Yeah. So, but in the modelings, we will try to combine. And before we talk about modeling, of course, between reporting and modeling, we will have this one, the combination between diagnostic and descriptive that mostly work for exploratory. Yeah. So this is like what we has done in the exploratory data analytics. Yeah. But when we do the modeling for predictive, yeah, so we will discuss about the future based on the past and present, yeah, and then of course we're using the what if also, do some mechanisms and less about detail. So in here we will more focus to develop the predictive modeling, yeah, do some forecasting, yeah, and then do some optimizations, and then statistical analysis, build some system dynamic model, agent-based model, and we do some scenario thinking. Yeah. So this is will be like our how we think to develop the model for predicting, and then do some predictive, prescriptive, and cognitive analytics. Yeah. So that will be the challenge here. So when we do the more focus on the diagnostic analytics, yeah, we will usually perform using some technique, yeah, like data discovery. We do some drill down, data mining, and also correlation. And in the discovery process, analysts identify the data source that will help them interpret the result, yeah, to come out with the insight. When the drill down involve focusing on certain facet of the data or particular widgets, yeah, yeah. So that would be many platform that we can use for this one. I think like Google Data Studio, Power BI do the same scenario, yeah. And also the data mining. The data mining is automated process to get information from massive set of raw data, yeah. This is finding consistent correlation in your data, and then help you to pinpoint the parameter of the investigation. So it will be the nice one, yeah. So yeah, of course, when we do the data analytics, is the benefit is data play an ever increasing role in every company. Yeah. Using the analytics tool will allow you to get the most out of it, translating your complex data into visualization and insight, and that everyone can take advantage of. Yeah, so that will be the nice one. And of course, you will can answer your data question. Yeah. And then the data analytics help you get value out of your data by asking the right question and making deep dive for the answer. Yeah, so that will be yeah, is close with the business intelligence activity actually when we do the data mining. Yeah, so because we need to answer a lot of question actually from this one. Yeah. So that will be the nice one. So actually in this diagnostic analytics, we will focus on the how we this one. Yeah, try to drill down and query the data, and then we try to do some discovery and all that for this. So I will back to our our use case in here. Yeah. So later on, I will share you a data set that I collect from this project, yeah, from the COVID-19 project, into and upload to the log. Yeah. And then I will challenge you to use some tools you can choose by yourself. Maybe you can use the Google Data Studio, or you can use like Power BI, and also you can also other tools like you also using the maybe like data mining tools like K9 or maybe Orange or other tools is up to you, or you want to handle by your own hand using the Python programming and so on. What I want you to exercise is you can use this benchmark from your covid19.gamabox.id that we has done, and then try to think about how you will you will result a diagnostic analytics result based on this data. The data is actually is very simple, yeah, because I will show you the data set. Yeah, so the data set is like this one actually. Yeah, this is the data set. We have the 4 sheet of data set. Yeah, this is actually is already data set that has been prepared by the team. Yeah, if you want to know about the core of the data, the very raw data that we collected from the social media and then from the formal source of data from the government, you will see more it's not as clean as we has done. Yeah, so this is like the number. For example, this is the case. Actually, this is the not the total. Yeah, this is the time series. It is from the start from the date, and then the accumulative number of case in every province is already placed in here, so you can see. And so and then we also have this one, this column that the title, the column is question mark. It means this is like the case that not specify in which in which province. So in here, I want you to diagnostic what happened in this data. Yeah. And then we also have the number of daily case, for example, in here. Yeah, it's also we also have this one. So that's why in here you can see this is like the province also. This is the number of the case that every day happen, and then you will find also one of the cool things is about the column that a question mark is also same with the previous one, but please be careful because in we will find a number that have a negative attributes. Yeah, actually it is like a adjustment. So yesterday we found one case, but unfortunately is wrong. So we not delete this data, but we try to adjust by the next day. Yeah, so that will be the next one. So you need to take a look about it. Yeah. So this is like the number. Yeah. So we also have adjusting number that make it happen. Yeah. So it's also happen, and this is the number of case that already sembuh gitu ya, and then this is the already the a case that happened when some of the patient is meninggal dunia, for example. So this is like the main data set. So I would like you to observe this data set and then discuss with your team and discuss with your friend what kind of diagnostic analytics that you can use here. So you can use based on my presentation about the diagnostic. Yeah, try to make it drill down. Yeah, you can find the correlation. Yeah, I think based on the province, based on the island, and then maybe based on the closeness of the province, for example, it also will be the pathway to drill down the data. And then you can see another things. Yeah, so that will be the diagnostic. And I think that the example is you can access from my project in here. So this is the project. I think it's already have a diagnostic analytics, but still in the it's very general model from my team. So hopefully you can found you can and then you can find a new perspective how to do the diagnostic analytics based on data. So I will not give some limitation about what number of report that you can bring to us, yeah, next week, yeah, and then you present to the class, yeah. But it's up to you. If you have found one, it's okay. If you have found two or three, the type of the visualization or something, you can report and we can discuss later on, yeah. It's okay, yeah. So that would be the nice one. And and the tools is, yeah, my team is choose the some of this one, the data studio is more because it's more easy to use and then more familiar, yeah, for early adopters data scientists to working on with data. So that will be the reason actually. So but I think because you are the computer science, I think you will found more advanced analytic from here. So I think we will try to working with the same data for all students, and let's see, or maybe we will found if we have 20 or 30 people, maybe we will have a 30 point of view diagnostic analytics that we can produce from every student. So that will be also the nice one. Yeah. So that will be your journey. So if you have any question, please give your question to me. Okay, no question. Okay.